Okay, so now we're going to be looking at what can happen when we have two planes, okay? If we have two planes, there are three things that there could be about these two planes. Like they could intersect each other, they could be parallel to each other, or they could, in fact, be the same plane, okay? Now, I'm just going to deal with what happens if we have two planes that are parallel to each other. Now, for example, we might get a plane 2x plus 3y plus 4z equals 1, okay? Now, that means that the normal to this plane is equal to 2, 3, 4, and we might get another plane that has 4x plus 6y plus 8z equals 11, for example. Well, the normal to that plane is 4, 6, 8, which is the same as two lots of 2, 3, 4. So we can see that the direction of the normal vectors of each plane are the same. That is to say, we've got something like that. So therefore, they must be parallel. So if the normal vectors are parallel, then so must the planes be parallel. So you need to be on the lookout for that. And of course, I think if I change this to 2, well then now we've got the situation where they're coincident, they're actually exactly the same plane. Okay? Obviously, because what I could do is on this one, I could factor out 2 on both sides and then divide by 2, it would turn into the same plane. So they'd be the same. Now, where it gets tricky is what happens if they're intersecting planes. Now, if they intersect, there will be a line of intersection. This is a line of intersection, not a point of intersection. There will be a line of intersection. And so what you might be asked to do is find the equation of the line of intersection. Okay? So let's have a look at how this works. Okay? So we've got two planes, 3x plus y minus 2z equals negative 1, x minus 4y plus 2z equals 3. Find the equation of the line of intersection. Now, what we're going to do is we're going to write them as simultaneous equations. X minus 4y plus 2z equals 3. So here's equation 1, here's equation 2. Now what I'm going to do is I'm going to see, can I eliminate any of the variables? And I can eliminate z pretty easily if I do equation 1 plus equation 2. So what does that mean I'm going to get? It means I'm going to get 4x minus 3y, z's will be eliminated, is equal to 2. Okay? And now what I'm going to do is I want to know what I'm looking for the parametric version of this line. Okay? So I'm going to arbitrarily set x to be equal to lambda. Okay? I'm going to set x to be equal to lambda. Now if I do that, I'm now going to sub lambda into this equation, which I'll call equation 3. So sub lambda into 3. That means I'm going to get, let me just change colour now, 4 lambda, because x is equal to lambda, minus 3y equals 2. So that means negative 3y is equal to 2 minus 4 lambda. So y is equal to 4 lambda minus 2 over 3. So basically I'm dividing both sides of that equation by negative 3. So here we go, we've got another equation. Y is equal to 4 lambda minus 2 over 3. Now what I'm going to do, I need to basically eliminate, I'm going to get rid of all of this. And what I need to do is I need to go again. Now, this time I'm going to try and eliminate y's, not z's. Okay? So what I'm going to do is I'm going to multiply equation 1 by 4. then I will get 12x plus 4y minus 8z equals negative 4. And equation 2 won't change. I'll get x minus 4y plus 2z equals 3. I can now add again, because that will eliminate y. So I'm going to get 13x. Then minus 8z plus that's going to be minus 6z is equal to minus 4. That's going to be equal to negative 1. And again, what I can do is I can sub in lambda. Sub lambda into that equation. So I'm going to get 13 lambda minus 6z equals negative 1. So now I'm going to rearrange to make z the subject. So 6z is going to be equal to 13 lambda plus 1. So z is going to be 13 lambda minus 1 over 6. Okay, and so now I can write that in as well. Z is equal to 13 lambda minus 1 over 6. And there we have the parametric version of my my straight line. Okay, so from that you should be able to turn that into a vector equation of a line or a Cartesian equation of a line, however you need to do it. Okay, now you're then asked to determine the angle between these two lines. Well, that'll be easy. We just did that. So we use the formula cosine theta is equal to mod n dot d over mod n mod d. And what is n? N is going to be equal to 3, 1 minus 2, so n1. So that should be n2 and n1. Okay, because we've got two planes, not a plane and a line. Okay, so n2 is equal to 1 minus 4, 2. Okay, and you can go ahead and find the angle between those two planes. Okay, I'm not going to do that because we just did it before. Okay, so I'm going to